We did this because we had an Indian satellite in the payload bay. We had to launch about 2 o'clock in the morning to get that satellite to the right place. And if you do the flight mechanics, a week later out of low Earth orbit, you're going to land somewhere around 2 o'clock in the morning. We got out on the launch pad. Jay Barbary is maybe here somewhere. He reminded me last night of us looking up into the night sky and seeing lightning. We were in the middle or surrounded by thunderstorms. I was convinced we were not going to go. I told the crew that. And then I was almost asleep at the 9-minute hold. And suddenly they said, "You're coming out of the 9-minute hold in 1 minute." But to make the first night landing was a real privilege, not only just for the test piloting thing of that, but with Joe, I had flown first Enterprise, which made all of this possible. Then we had backed up John and Crip on STS-1 and flew STS-2, so we felt like we had started it. And here was an opportunity to open a capability for the rest of the program. And it reminded me of when I went out to make my first night carrier landing, and I had a landing signal officer named Duke Hernandez, and I was kind of nervous and young, and he said, "Dick, don't worry about a thing. It's just like coming aboard ship in the daytime. You just can't see what you're doing." But standing in the way of making the night landing for Dan and me was the fact that we had a heads-up display in Challenger that we had not had in Columbia in the early days. And frankly, we felt like for the job at hand, we wanted a simple heads-up display that was simple and uncluttered so we could just concentrate on getting this bird home. And we just thought it had too many bells and whistles, and that needed changing. And the second thing that was in the way, we didn't have a night lighting system. And so during the couple of years before flight, we redesigned, with the help of many engineers and other guys in the crew office, we redesigned the heads-up display and got the support of the program office to change the programming of it, and we were satisfied with that. And then the other thing, the lighting system, we looked at flares and we looked at Navy Fresnel lens carrier systems, but it just wasn't bright enough, for the distances that we were expecting to see. So after working, and a lot of people up here and in the audience helped us by flying against these lighting systems on the ground. And I never looked in my logbook to see how much nighttime we got, but it was plenty. And in addition to Dan's and me spending all of our time on this, I've got to give credit to Mike Smith, who was killed later in the Challenger vehicle, because Mike, both in the HUD and in the lighting system, just did yeoman's work, and we would have never solved the thing without him. We ended up with a really simple system. It was made of automobile headlights, red and white. And for the pilots in the audience, it was very simple. If you were on the correct glide slope, you saw 2 reds and 2 whites. If you started going low, you saw then 3 reds, then 4 reds. If you were high, you saw more and more whites. Then we had the big xenon lights that illuminate the launch pad. We put them lined up directly down the center line, but way short of the runway, and turned them on so they they put a beam of light right down the runway, and as bright as they were, though, during rollout, I mean, the actual amount of light you could see out of the cockpit was measured in a handful of lumens. I mean, it was very dim, but you could see. And then for flare, we had kind of a takeoff on a Navy carrier lighting system that essentially was called a ball bar, a ball that showed you if you were high or low, and then a bar that showed you that you were on that more shallow glide path. Well, we flew the flight. We got to entry interface at 400,000 feet. Dan and I were pointed up at the 40 degrees up at the stars, and to start the entry. And as we went on, we noticed a funny thing. The stars began to dim, and they went out. And I glanced over at Dan. I thought, you know, going blind at this point is not a good idea. And then they started changing colors in all the windows. And as we realized that what we were seeing was the ionized gases in the foot-thick shock waves standing out in front of the orbiter as they heated up. And during reentry, we saw out of the windows every color of the rainbow. You couldn't see outside except for that. Finally got down to about Mach 7, and it was white hot looking out the shuttle windows. And again, we thought, okay, God, it's time to let us see. And suddenly, just like this, it went away. We were in a steep left bank. I looked out, and it was the most gorgeous view of the California coast, Los Angeles, Santa Barbara, San Francisco. We rolled back up, and way out in the black, because there was no moon, I could see the Edwards, those xenon lights. We crossed over the field at 50,000 feet. At Mach 1, we put it into manual, and Dan and I flew it around the circle. And now it was the moment of truth as to whether the lighting system was really going to work. We rolled out, and it was the most beautiful sight you've ever seen. Right there in the center of the HUD was 2 reds and 2 whites. And we kept coming down, and by this time, those 2 reds and 2 whites was all we could see. We finally got low enough, about 3,000 feet or so, where the top of the frame on the top of the window covered the runway. We couldn't see that. We kept driving down to pre-flare, and we finally started a slow pre-flare. Finally, the runway came into sight, the ball bar, and we landed. If I remember right, 50 feet long and a half a knot slow from 4,000 miles out. So it was a hell of a ride.
Thank you, Dick. Eileen?
Well, good afternoon. I want to say, first of all, that it's really an honor for me to be up here with the shuttle commanders. And I have absolutely great respect for all the superior work that they did before I flew the shuttle, but before I even came to NASA, to make the shuttle so much safer as the years went by. But I'm here to talk about Discovery. I want to say a little bit about the history and the things that Discovery did. She was the 4th orbiter built. The contract went out in 1979, and she was delivered to Kennedy Space Center in 1983. Discovery's flown 39 times, first flight in August of 1984, and the last flight and final flight was just last month, March of 2011. Some of, I would say, the more famous missions that Discovery flew, she launched the Hubble Space Telescope, flew the return to flight mission after the Challenger accident and also after the Columbia accident. Discovery performed the first rendezvous with the Russian space station Mir. She carried the oldest person into space, John Glenn, at age 77. And Discovery flew the first cosmonaut on an American spacecraft. That was Sergei Krikalev in 1994. Discovery has a cumulative days in space of almost a year, almost 365 days in space. And of its 39 missions, 13 of them have been to the International Space Station on assembly and resupply. So Discovery has flown its last flight, and soon you'll be able to see it up close in the Smithsonian. Now, we've been asked to really answer two questions. Is there something about your orbiter that makes it different from the others? Is it unique? And also tell a personal story about a mission that you flew on that orbiter. So the first half of that, is there something unique? You know, I thought long and hard about it. Other than the history behind each orbiters, they're really pretty much the same. Really, the only differences are in the payloads that are flown, and that'll change the weight in the center of gravity. And also, occasionally, they'll change the panels, or maybe they'll change the switches and circuit breakers. But other than that, they were pretty much the same. From a pilot's point of view, as far as flying the orbiters, and are there any differences in the handling qualities? Or, you know, if you put yourself in one of them, would you be able to guess which one you were flying? And I would say no. Due to the great work that was done by Joe Engel and his group, the flying qualities of the orbiter were actually very stable and predictable by the time I flew. I made my first landing in 1999. But I will say that the pilot will notice a difference, not by the orbiter, but by the weight and the location of the center of gravity. For example, if you're flying a lightweight orbiter, like when I flew Columbia back after deploying the Chandra Observatory, we were totally empty. We were very lightweight. And you notice that the flight controls are a lot more responsive, and maybe it's just a little bit easier and more predictable to fly and to land. But with a heavyweight orbiter like we had on Discovery, coming back from the space station with a full load in the logistics module, I noticed a delay and more sluggish flight controls. Fortunately, all of those flying characteristics can be programmed into the software in the Gulfstream that we fly.